All right, worksheet 3 is practicing using Newton's second law. I'm going to do the first one here as an example. They're all similar form. Um, Newton's second law was introduced to you this way, with F being the net force. Well, you'll remember sigma F is a symbol for net force, so get used to seeing it written like this as well. Still Newton's second law, be more explicit here that the sum of the forces is the net force. So in the first one, a 2 kilogram cart, recognize that's mass, on a frictionless tracks pulled horizontally by a force of 3 newtons. What's the acceleration of the cart? On all these, you're going to make a sketch, and here's my sketch of the situation. Draw a well-labeled force diagram. That's what I have drawn here, showing the gravitational force, the normal force on this level surface, and I know that those are the only two forces. Since there's no acceleration vertically, those are balanced, and there's just one unbalanced force here. So the third thing to do is write the net force equation. So in X, it's simple. There's only one horizontal force, and it's 3 newtons. In Y, it would be the gravitational force down, which is mass times acceleration due to gravity, and that's downward, so that's a minus 20. And the upward normal force is plus 20, and then plus minus 20, the gravitational force, which equals 0. So that means the horizontal force is the net force. And now what determine the horizontal acceleration? Well, I can specify horizontal acceleration with a subscript. And acceleration equals the sum of the forces in the x horizontal direction divided by mass. In this case, it would be 3 newtons, and the mass of the cart is 2 kilograms, and acceleration horizontally therefore equals 1.5, and the units are going to be meters per second squared.